Greetings and salamanders, everyone. Welcome to chemistry. This is our next lecture all about atoms. Now, I know you have talked about atoms at some point in the past, whether it's sometime in middle school or biology or wherever, or maybe this is your third or fourth time taking chemistry. You're just trying to get a better seat each time. Anyways, today we're going to talk about kind of the core concept of atoms and do a little bit of review. All right. Okay, so let's get the basics out of the way. Everyone knows that all atoms contain three things. Things we call protons, neutrons, and electrons. Most of you know that atoms are spherical, and granted, this is a two-dimensional arrangement here, but the nucleus of an atom is the place where the protons and neutrons sit. You may know that protons actually have a charge. Protons have a charge of what we call +1. Now you have to be careful with the positive. The positive does not mean addition here, which is totally counterintuitive. The positive literally means the type of charge. All right, so this does not mean +1 at all. So protons have a charge of +1. Neutrons, what do we know about neutrons? Neutrons are what we call neutral, and it's a great way to kind of memorize the difference between a proton and neutron in terms of the charge. They are neutral. They have no charge. What is interesting about protons and neutrons? So see if I can spell. Protons are about exactly the same size as a neutron. So they're like twins, except not twins. They're like, what's the non-identical twins? Fraternal twins, right? About the same size. They both sit in a nucleus, and one of them has a charge, the other one does not. The electrons are the things we see kind of flying around here on the outside. Electrons have a charge as well, but this time it's a little bit different. Protons have a charge of +1. The electrons have a charge of -1. Again, don't get hung up on the minus. The minus is not subtraction. It's telling you the type of charge. I've got positive charges from the protons. I've got negative charges from the electrons. Um, okay, so these are the basics on atoms. And honestly, I'm going to assume that this material is review. There's a lot of material we're going to cover this year, and you may know that these electrons sit in shells. So there's a first shell, second shell, third, and I'm hoping you know that first shell holds 2, second shell holds 8, third shell can hold 8, and so on. We're going to get a lot of practice talking about that, so we'll try to improve or refresh your knowledge in certain ways. Now, talking about these electrons, it's important to point out the electrons are really small. They are about 1/2000th the size of a proton. So that's pretty wild. And in fact, I want you to think about this. If you actually had a football field, and here is the end zone, and yeah, right, that's actually the 50-yard line. But if you actually took an atom, and let's take the simplest atom that we know of. The simplest atom that we know of is hydrogen. Hydrogen has one proton and one electron. The point that I'm trying to make right now is that atoms are mostly empty space. And what I'm talking about right now is if you imagine the space between the protons and the electrons, this space in here, and even the space, to a certain extent, the space between the electrons. If you took the atom hydrogen and took a proton, and a proton is really small, so I'm going to use this color to represent a proton. If a proton was the size of a tennis ball, and the tennis ball represented the proton, the nearest the electron would actually get to it would be the end zone. So what's in between? Absolutely nothing. So we tend to think of atoms as being pretty dense. It turns out they're hardly dense at all. All right, so I want to kind of stop right there and kind of move on a little bit. Now, as you start to get more familiar with the periodic table, you know the periodic table is nothing more than telling you the different types of atoms. you start to get a feel for the information that's on there. And there's really three pieces of key information that's represented on any element on the periodic table. The first is obviously the name or the chemical symbol. Atoms, it's kind of tricky, the symbols that we use for atoms. You might tend to think that iron has a symbol IR, but IR is actually for iridium. The Fe for iron comes from its Latin name. Or better yet, the name for sodium, the chemical symbol for sodium is Na, because it comes from the Latin for natrium. So a lot of names you see in the periodic table actually come from their Latin names. Okay, so don't get hung up on that. I don't expect anyone to memorize the names of atoms. That's just silly. Two other bits of information. Something we call the atomic number and something we call the atomic mass. I think people kind of get a feel for atomic mass. They're like, yeah, okay, it's got mass. Atoms are heavy. They weigh things, right? Where do you think the weight of an atom comes from? The bulk of the weight of an atom. If you remember before, I said protons and neutrons are about the same size. And that's it. The mass of an atom, this number we see down here, comes from adding up all the protons and all the neutrons of an atom to get its mass. And it turns out for carbon, if you did that, if you added up its protons and neutrons, you'll actually get 12. Uh-oh, this is 12.01. Where does that come from? Well, it's actually an average mass, and that's going to be the subject of another video. But for now, let's just assume that's a nice whole number. Okay, so the mass comes from adding up all the protons and neutrons. Fine. What's this thing, atomic number? Atomic number means this. I'm going to change color. Atomic number tells you this, the number of protons. Atomic number only tells you the number of protons. So I can automatically look at carbon and say, oh, carbon has 12 protons, carbon has a mass of 12. Well, think about this. How many neutrons does carbon have to have? And if you remember our discussion before, the mass of an atom comes from adding up its protons and neutrons. How do you think I could get the number of neutrons in carbon? Well, I could probably take its mass, 12, subtract the atomic number, and I'd get 6, which is the number of neutrons in carbon. So it's not that bad. We can do pretty easy calculations just like that. Okay, so let's go a little bit deeper into this. Okay, let's take a look at the iron atom, all right, or as Bugs Bunny says it, iron. Uh, Iron has the same two things on here. This is atomic number. Do you remember what atomic number means? Kind of refresh yourself, pause the video, go back. You're right. Atomic number is always describing the number of protons. All right, so iron always has 26 protons. The mass on the bottom, do you remember what the mass is a sum of? The mass you get from taking all the protons and adding all the neutrons and getting together. And remember, this number on the bottom is an average mass. Okay, so how do I find the number of neutrons in this case? Well, I'll do the same analysis you did before. Take 55.85, but what I tell people to do is round this up to the nearest whole number. So 55.8 actually gets rounded up to 56. And that's okay, and this to making a little approximation. So 56 is the mass, and subtract from it what you know. You know the number of protons, 26. So 56 minus 26, that gets me blah, 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 75. Nope, sorry, just kidding. That gets you 30. So the iron atom has to have 30 neutrons, okay? Now, here's something I didn't say before. All right, this is really important. The number of protons in any atom does not always equal the number of neutrons. Don't get caught up in that. And this looks really awkward. Right? That's supposed to be a number sign. Number of protons does not always equal the number of neutrons. But the following is true, always. The number of protons is always equal to the number of electrons. And the reason is this. Protons have a +1 charge. Electrons have a -1 charge. We have to have an exact balance of positive to negative charges. In this case, a +1 will balance with a -1. Well, let's take the example for iron. iron has 26 protons. That means we could add it up to get a plus 26 charge. I have to exactly balance that with 26 negative charges so that I end up with, if I actually took plus 26, 26 minus 26, I would actually end up with 0. Okay? And I don't know what that is right there, but I'm just going to draw a little face. Okay? It's like, oh, it's like a little pig. See a little pig, and he's got the little ears. Okay, it's never drawn that before. But anyways, this point is really important. Number of protons always equals number of electrons, right? Because you're going to get quizzed on that. Okay, you ready for the advanced stuff? Here's the advanced stuff. Okay, here's the advanced stuff. See this average mass? Why is it an average? Why isn't the mass a whole number? I've been telling you for the past 10.48 minutes that the number of protons, if I actually took the number of protons plus the number of neutrons, I get the mass. So how the heck am I getting a mass of 55.845? Can I have 0.845 of a proton or 0.845 of a neutron? No way. You can't have part of one of those things. So enter what we call an isotope. Well, it turns up, just got another text message. It turns out sometimes atoms can actually have more neutrons. And I know some of you aren't going to like this because it makes things a little bit more complicated. But sometimes atoms can actually have more neutrons. And what I'm talking about here is most iron atoms. Most iron atoms that are out there. Well, first of all, every iron atom is going to have 26 protons. And most iron atoms are going to have 30 neutrons. And if you added those two up, if you add up those numbers, you get what? You get 56. But you notice our average is not 56. Our average is a little bit lower. So the only way this can happen is if sometimes some iron atoms that have 26 protons, instead of having 30 neutrons, they'll actually have 29 neutrons, which adds up to a mass of 55. And if you guys remember how to find the average of something, you add everything up and then you divide by the number. Like say if I had 100 iron atoms in a box and I added all the masses of all the iron atoms up and then divided by 100, I would actually get an average. So because this average is closer to 55.85, it's telling us most iron atoms have 30 neutrons. That's most of them. But some of them, some iron atoms will actually have 29 neutrons. These things are both iron. They're what we call isotopes. Isotopes will always have the same number of protons, but they'll always have different numbers of neutrons. We're going to go into more detail in isotopes in another lecture because there's a way you write isotopes, and isotopes kind of do weird things. They can be radioactive, which is kind of cool. But anyways, that's the end of this lecture. It's just an introduction into writing some of the more mathematical information about an atom. Okay? See ya.